Assalamu alaikum, dear students. Our topic is today nuclear reactor. We have studied about nuclear energy and nuclear fission reaction. Today we will talk about nuclear fusion reaction. But before that, I will talk about nuclear reactor. तो हम न्यूक्लियर रिएक्टर के बारे में थोड़ा सा डिस्कस करेंगे. न्यूक्लियर रिएक्टर इट्स अ सोर्स ऑफ इंटेंस हीट. ठीक है ना, इसमें हम इंटेंस हीट जनरेट करते हैं बाय बाय न्यूक्लियर रिएक्शन. क्योंकि हमें पता है कि जब न्यूक्लियर रिएक्शन होती है, न्यूक्लियर फिशन होती है या फ्यूजन होती है, तो वहाँ पे इंटेंस हीट, बहुत ज़्यादा हीट जनरेट होती है. यही हीट फिर हम यूज़ करते हैं टू प्रोड्यूस द इलेक्ट्रिसिटी. Here the steam is used to drive the turbine. As you can see here, the steam is coming from here, and this steam is then used to drive this turbine or run this turbine. And this turbine is connected to generators, and then the generators produce electricity. Basically, this nuclear reactor consists of three important components. First one is fuel element, second one is moderator, and then control rods. The fuel elements come with thin rods of about 1 centimeter. As you can see here are the thin. तो ये जो फ्यूल एलिमेंट है ये थिन रॉड्स का बना हुआ होता है of about 1 centimeter in diameter. And in fuel elements में या in rods में fissionable nuclei होता है. Fissionable nuclei जिसमें nuclear reaction हो जाए, which is capable to produce the nuclear reaction, like uranium-235 is a fissionable nuclei, and uranium-237 is also a fissionable nuclei. और ये जो rods होते हैं इसमें जिसमें fissionable nuclei होता है, they are immersed in water. And क्या काम है वाटर का? वाटर एक्ट्स एज ए मॉडरेटर. वाटर जो है ये एक्ट करता है एज ए मॉडरेटर. और इस मॉडरेटर का ऑब्जेक्टिव ये है कि ये न्यूक्लियर रिएक्शन को स्लो डाउन करता है. क्योंकि हमें पता है कि ये जो न्यूक्लियर रिएक्शन है ये इट्स अ चेन रिएक्शन. ये चेन रिएक्शन है, ये कभी ना ख़त्म होने वाली रिएक्शन है जब तक ना जो है सारा न्यूक्लियर ख़त्म हो जाए. तो वहाँ पे जो है एक अनलिमिटेड एनर्जी प्रोड्यूस होगी जो हम कंट्रोल नहीं कर सकते. सो टू कंट्रोल दिस रिएक्शन दिस वाटर एक्ट्स एज ए मॉडरेटर. ये न्यूक्लियर रिएक्शन को स्लो डाउन करता है बिकॉज वाटर कंटेंट्स. एंड देन द थर्ड कंपोनेंट इज़ कंट्रोल रॉड्स. तो ये कंट्रोल रॉड्स का काम क्या है? ये न्यूक्लियर रिएक्शन को कंट्रोल करता है एज द नेम सजेस्ट्स. The control rods control the nuclear chain reaction. Control rods absorb any excess neutrons in the moderator. ये न्यूट्रॉन्स जो एक्सेस न्यूट्रॉन्स होते हैं ये उनको एब्जॉर्ब करता है ताकि वो जो है न्यूक्लियर रिएक्शन जो है ना करे, यानी कि वहाँ पे फिशन ना हो जाए ज़्यादा से ज़्यादा. तो ये जो कंट्रोल रॉड्स है वो इन न्यूट्रॉन्स को एब्जॉर्ब कर लेता है. दिस मीन्स दैट these control rods absorb any excess of neutrons in the moderator. Usually such control rods are made up of boron and cadmium. बोरॉन और कैडमियम से ये जो कंट्रोल रॉड्स हैं बने हुए होते हैं. एंड तो ये तो हमने कंपोनेंट्स की बात की कि कंपोनेंट्स क्या क्या होते हैं न्यूक्लियर रिएक्टर में. अब ये वर्क कैसे करता है, हाउ डज इट. ये तो हमने कंपोनेंट्स की बात की. अब हम ये देखेंगे कि हाउ डज इट वर्क. ये एक्चुअली वर्क कैसे करता है. So this nuclear reactor consists of three parts. One is reactor core. This is reactor core, and second is pump. This is pump here, and third one is heat exchanger. This is the heat exchanger. The reactor core and pump are placed in contact with the water. Okay, here this is the water. The water continuously goes here and comes down. Okay, goes here and comes down. This is the function of this pump. It continuously drags this water in and out. So this reactor core and pump are placed in contact with water. During the enormous amount of heat released during fission reaction, the water gets heated. As you can see here, the water gets heated. The heat is transferred from here to here, and this water gets heated up. And this water changes into steam. As you can see here, this changes into steam, and in turn it's used to run the turbine. As you can see here, the turbine is running. So the huge heat energy gets converted into this kinetic energy. Here is this the heat energy, and this heat energy gets converted into mechanical energy, which is here kinetic energy, and this kinetic energy then runs the generator. So we can say that the nuclear energy is also the renewable energy, which can be renewed. Okay, and the vast majority of the electricity from nuclear power is produced by nuclear fission of elements in the nuclear reactor. And nuclear power is the fifth largest source of electricity in India, after coal, gas, hydroelectricity, and wind power. There are several reactors in India in operation. For example, Kaiga nuclear reactor is there, which is in Karnataka, and Kakrapar nuclear reactor is there, which is in Gujarat, and Kundankulam nuclear reactor is there, which is in Tamil Nadu, and Kalpakam nuclear reactor is there, which is in Tamil Nadu, and Narora nuclear reactor is there, which is in Uttar Pradesh, and similarly Rana Pratap Sagar and Tarapur nuclear reactors are there in India. Let me talk about now nuclear fusion reaction. We have talked about nuclear fission, and I will talk about now nuclear fusion. So nuclear fusion occurs when the two lighter nuclei join to form a heavy nucleus. Okay, two lighter nuclei fuse each other, and they form a heavy nucleus. And in this process, they release the tremendous amount of energy. They release the tremendous amount of energy, as can be seen here. This is the deuterium, and this is tritium. Okay, this is deuterium and this is tritium. They fuse each other. They fuse together to form a single nucleus. Okay, to form a single nucleus, and releasing one neutron, and the tremendous amount of energy. And basically there are three isotopes of hydrogen, and I hope you have studied about the isotopes. There are three types isotopes of hydrogen. One is hydrogen itself, and second is deuterium, and third is tritium. So there are three isotopes. The difference is that they have the same proton, that is Z is equal to 1. Hydrogen has got one proton, and deuterium has got one proton, and tritium has got one proton. But the difference is that they differ in a number of neutrons. Okay, hydrogen has got no neutron, and deuterium has got one neutron, and tritium has got two neutrons. So there are three isotopes. And here the reaction takes place between deuterium and tritium. Okay, deuterium nucleus and tritium nucleus fuse each other, and they form a single nucleus, which is helium. Okay, which is helium, which has got Z equal to 1, and mass number has 3. And in this process, the tremendous amount of energy is released, and one neutron is also released, as you can see here. One neutron and 3.5 mega electron volt is released here. So the nuclear fusion reactions are the source of energy in the sun and other stars. And in sun and other stars, the nuclear fusion takes place in those stars and sun. And in order to fuse, nuclei require a considerable amount of energy, extremely high temperature and pressure conditions, about millions of degrees of temperature, and millions of pascals of pressure. So the situation should be that the nuclei will require the high temperature and high pressure conditions. So developing technologies to harness the nuclear fusion as a source of energy for heat and electricity generation is the subject of ongoing research. But will it be a commercially viable technology? Is not yet clear because of difficulty in the controlling fusion reaction. So it is a topic of ongoing research. The researchers and scientists are researching about it. That how can we control this, or how can we produce this tremendous amount of temperature in order to this harness this nuclear fusion reactions, because this is not the simple condition in which we will do this nuclear fusion. It requires the very high temperature and very high pressure conditions. So this has to be harnessed in a very suitable environment.